Hello guys, and my name is Parinitham and I'm studying in Sri Venkateswara College of Engineering, and today I'm here to talk about on the topic of IDE for embedded systems. So let's get down straight to the contents. We'll be talking about introduction to embedded systems design, feature of an embedded system, types of embedded system designs, benefits of using it, factors, demo examples of embedded system using IDEs in action, and conclusion and future developments of it. What is an IDE? IDE is an are software applications that provide a comprehensive platform for developing software that integrate multiple tools and simplify by automating processes, allowing developers to streamline and improve their workflows. Code editor allows developers to write, edit, and debug code efficiently. Compiler converts the code into an executable format for the target hardware. Debugging tools. These help in identifying and fixing errors in code and hardware components. Project management tools coordinate team collaboration and version control in large software projects. The power of IDEs in embedded system design. An integrated development environment is a software application that provides a set of tools for software development and programming languages all in a single graphical user interface. IDEs typically pack a source code editor that assists in programming with features such as syntax highlighting, language-specific auto-completion, and a debugger for testing code and routing out bugs. In essence, IDEs enable programmers to maximize productivity without the need for multiple utilities that have to be configured and implemented for each application. Because utilities are housed under a single GUI, developers can execute actions without switching between applications. So now we are going to talk about the popular IDEs for embedded system design. WebStorm is an IDE which performs auto-completion on the fly code analysis, code navigation, refactoring, debugging, and integration with version control systems. It also supports multiple nesting, example when a JavaScript is embedded in a HTML document in which the HTML code is embedded. MPLabX is also another example of an IDE embedded system. In this latest version of integrated development environment, MPLab created by Microchip Technology Company, the software is based on the open source NetBeans platform and is designed to create applications for various types of PIC microcontrollers and digital signal controllers. Eclipse, as you know, it's a basic Java coder, and it's initially the Eclipse in integrated development environment was created for Java applications, and now it is the most widely used solution for by Java programmers. Nevertheless, Eclipse can work with other programming languages: ADA, ABAP, C, C++, C hash, Python, PHP, etc. via plugins. So the next topic we're going to talk about is integrated development environment versus separate tool chains. By using IDEs, what and all advantages we're going to have versus the separate tool chains, we're going to talk about higher productivity. IDEs automate tedious development tasks, reducing time and errors, which means like it reduces the time taken to develop or do your tasks. So it will reduce the time and make the work more faster. Wider support. IDEs typically support multiple hardware platforms, languages, and frameworks. Better compilation and debugging. IDEs offer tight integration between tools, making it easier to debug and test code. It takes less time to find out the errors and debug it and give a solution fast. Today, now we are going to talk about the performance consideration of for IDEs in embedded system design. The performance depends on the following IDE factors. Processor load. It mainly depends on the processing power of the RAM and the CPU of the hardware platform you are using. So you should have a better RAM power and CPU power for the IDE to perform the tasks at optimal speed. Code size. IDEs generate more source code, which means larger size and reduced storage capacity. Be mindful of the limited resources of the embedded systems. Tool integration. Choose an IDE that integrates efficiently with your hardware components, software libraries, and development tools for better performance. We're going to talk about the tips for optimizing embedded system design using IDEs. Choose the right IDE. Considering the hardware performance and the software capabilities of the current platform you're using, you should use an ideal IDE that fits your project so that you may take less time for developing tasks and managing. Optimizing your code. Check your code for inefficiencies such as redundant functions or variables. Optimize where possible to reduce code size and memory usage. This tells us that the code size will be more and the memory usage will be less to store. So they're telling us to reduce the code size and not to frequently use the same variables and the functions again and again in the program. So test your system on real hardware platforms. Simulation and emulators don't give an accurate representation of the system's performance. So test on real hardware for more accurate results. So they're telling us that don't test these IDEs on simulations and emulators, which does not give an accurate representation of the system's performance. So better to check it out on your own hardware platform. So now we come to the conclusion. IDEs are powerful tools that simplify embedded system design and improve development productivity and increase efficiency. Choose carefully and optimize your code and for optimal results. It tells us that IDE it improves the development productivity and increases the efficiency when you op, choose the optimal IDE on which platform you're working on. An IDE can improve the productivity of software developers. Thanks to the fast setup and standardization across tools, without an IDE, developers spend time deciding what the tools to use for various tasks, configuring the tools and learning how to use them. An IDE can improve the productivity of software developers where it standardizes the tools and tells them which or helps them to use which tools you require for various tasks and these ideas improve productivity by lessening the setup time, boosting the speed of development tasks, keeping developers up to date to the latest best practices and threats, and standardizing the development process so that everyone can get on board. The ideas improve productivity. Like in the previous point, it boosts up the development speeds as it gives the software users, developers the required tools to which they have to work on and develop tasks up and it uses the latest practices and threats and keeps every user up to date so that everyone can get on board. And thank you for watching this video.